Hey everyone, welcome to part 3 of the sensor fusion tutorial. Today I'm going to talk about getting the data for it. So we've already downloaded the data to our collab environment using this wget command, and the overview video I show you how to do that. So now we've already imported the libraries, and now basically we just go to the data path and we can use the glob API to read in all the image paths. We can do the same thing with the LiDAR data and the GPS data, and we can see we have 837 frames. So now we're going to talk about how to read in the coordinate transformation data. So these are going to come from the calibration file, and you can see in the downloaded folder we have several calibrations. Right now we're going to focus on this one called cam to cam. So what cam to cam is, it basically has all of our camera parameters. I think it even has distortion coefficients. So this first thing we're going to read in right here is the projection matrix, and that we're going to use the projection matrix for camera 2 because this is our left color camera. And as a reminder, the projection matrix allows us to go from a 3D point in the real world and project it onto our 2D camera plane. And we're also going to take the rectification matrix for camera 2, and we're going to put this into homogeneous coordinates. We're going to add our zero translation vector since this is a 3x3 matrix. And we're going to put it into homogeneous coordinates by taking zeros for the rotation and ones for the translation. We can put a cell under here and you can see what it actually looks like. So you can see that this is the original, this 3x3 area, and this is the zero translation and the extra row that we've added to make it homogeneous. So we're also going to take this rigid transformation that allows us to go from camera 0 to camera 2. Since the reference is basically just camera 0, and we can see right here, this is our reference right here at camera 0. We want to go to camera 2 right here. So this next thing that we get right here, we just basically make this a single rigid transformation by combining the 3x3 rotation and the 3x1 translation, and then making it homogeneous like we did above with the rotation. And then this next thing right here, we're going to work with the velo to cam and IMU to cam. So the velo to cam and the IMU to cam are just the same thing, rigid transformation. We have a 3x3 matrix and a 3x1 vector. So right here I have this function imported. So we're gonna go over this. So this function is called get rigid transformation. So right here, basically reads in the file path. That's the same format for both. These files are both in the same exact format, so I grab it at the same exact line, and then I simply combine them together and make it homogeneous and return it. So now we get these homogeneous rotation matrices that will allow us to go from LiDAR to camera reference. So basically a 3D point from the LiDAR's point of view to a 3D point to camera 0's point of view. And now in this part right here, if we've read in everything right and not messed anything up, we can actually combine these transformations into a single matrix. So what I've done is I've multiplied the matrix that goes from the LiDAR to the camera 0 reference. I have one that goes from camera 0 to camera 2. I have one that goes from camera 0 reference to rectification 2, which corresponds to our camera 2, and then I have our rectification 2 to camera 2. So this projects it into 2D space. So this right here is a 3x4 matrix. I've added this in the commas just to remind me. So this will basically take us from a 3D point that the LiDAR sees to a 2D point that the camera sees. And we could also do the inverse. So in order we can't invert a 3x4 matrix. We have to make it homogeneous, and that's what this step is doing right here, just adding a row to it. And this one right here is a 4x4 matrix that'll allow us to convert a camera space point and homogeneous coordinates to a LiDAR space coordinate and homogeneous coordinates. And of course we're going to have to undo the homogeneous transform and that. So that's what it's a 4x4 matrix. So then down here we basically add a new transformation that's going to come in handy. We simply take this velo to cam and we compose a 5th transformation to it. So we have 5 transformations in this matrix right here. And once again, this is a 3x4, so this will allow us to go from a 3D point from the IMU to the camera. But where we're really going to use this is we're going to take a 2D point from the camera's point of view, assuming that we have depth from the LiDAR, and we're going to rotate this to the IMU. And this is going to allow us to detect objects relative to where the vehicle is. And this is going to come in handy in the future if we want to use vehicle motion data, such as lat long and outs, that's going to be relative to the IMU. So that's all for this video. I'll see you on the next one.